Hey guys, welcome back to the video. In the last video you have seen about cryptographic. Alright, so part 1 and part 2. If you haven't watched it, go watch the video and then come to this video. Alright, in this video we will be looking at hash functions and hash values. What are the types of hashing techniques basically, and where are they used in the real world. Alright, so let's continue with today's video. First of all, imagine a scenario where you are downloading 6 GB file, but at the end the question is, how do you know whether the file that you have downloaded is it the original one? How do you authenticate? Alright, so that is the problem of this. Or even someone gives you a file via USB, how do you verify its authenticity? Alright, that is where the hashing comes into play. Alright, let's check it out. How does it finds the solution? The solution is nothing but hash values. Alright, how it finds the solution? It basically compares hash value of both files. It will create the hash values for any kind of input, and then it will match those both are identical or not. So if it is identical, that means it is the original one. If it is not, that means it is the duplicate one. Alright, so next let's check it out. What is hash values? First of all, hash value is a fixed size string derived from data. Imagine it as some input will be given. Basically think it as any input. Example, one photo. So all the pixels value and all will be having some input, right? That input is passed into the hash function, and then it will give you a fixed sized string derived from that data. Alright, so generated using a hash function. There's something called hash function. We'll look upon it in the coming slides. Even a tiny change in the file will create drastic different hash. Alright, it is like a butterfly effect. Even a small change in the input will create a drastic change in the output. Alright, let's see how it is. So first, what is hash function? So basically hash function takes input of any size and then it will create the output. Alright, so not encryption. It is not encryption. Again, don't confuse with encryption because no key is involved. We have seen the symmetric and non-symmetric key. Alright, and next is one-way function. It is, what is one-way function? Basically it is irreversible. Once you melt the ice, even if you try to form it in the same format, you can never form it because it have melted once, and even if you try to put it back, it is irreversible in nature. Alright, so just like that, hash function is also irreversible in nature. Next is converts data of any size into a fixed size digest. Alright, basically imagine it as any input given to this hash function, it will create one particular fixed size output. Alright, for different inputs it will be different outputs. Alright, next it is properties of a good hash function. How do you say that it is a good hash function? First of all, it should be unpredictable in nature. If it is predictable, then it is not a good hash function, obviously, right? It should be unpredictable. Second is irreversible. Again, I told you that it should be irreversible. Otherwise, if someone knows the output, they should not be able to find the input. Alright, fast to compute but slow, impossible to reverse. Reverse should be impossible. Next, it creates an avalanche effect. What is avalanche effect? It is nothing but butterfly effect. Tiny changes in any input should drastically change the output. Alright, next let's see an example what I'm talking about. Imagine there is two files, file 1 and file 2 contain T. File 1 is T and file 2 is U. So hexadecimal is basically 54 and 55, and binary input, if you see, both are, the only difference is the last bit. One is 0, one is 1. But if you try to find the hash values of both of it, that is SHA-256 is one of the hashing techniques. If you want to find the SHA-256 hash values, then it will be something like this, a huge value, but the size is fixed. The only difference is both are drastically different in nature. Alright, that is the whole point of hash functions. Alright, next, what is hash collision? Alright, what is hash collision? Hash collision occur when two different inputs will give you the same output. Alright, so again, nothing is perfect in this world, right? Even hash function is not perfect. Ideally, hash function avoid collision, but sometimes it may get, alright, in huge number, like trillions and trillions, it may give us some one or the two collision, that is same output. Alright, next is why do collision happen? Let's understand that. First of all, it is unlimited inputs are there. Unlimited inputs means, imagine I'm clicking a picture, an image, that input, alright, take it as an input. So huge data is there in the internet, and every time it is new inputs. So basically it is unlimited inputs versus output is limited. Why? Because it is fixed size in nature, right? So inevitable collision have to happen at some point. Alright, known as the pigeonhole principle. What do you mean by pigeonhole principle? Imagine there are 5 pigeonhole, but there are 7 pigeons. So you have, in some holes, pigeon will be common in nature. Alright, because pigeonholes are less and pigeons are more. Alright, this is known as pigeonhole principle. Next, 4-bit hash numeric example. Let's see it with an example. 4-bit hash, if it is there, it is, how many possibilities are there? It is 2 to the power 4, that is 16 possibilities. But possible inputs, it is basically unlimited, but high probability of collision. So if it is 4-bit hash, it is high probability of collision because it has only 16 possible outputs, right? But what do you, if I ask you what do you mean by good hash function, then it is nothing but a hash function that will give you accidental collision. Alright, it should be very rare. Engineered collision, extremely hard. Basically planned collision should be extremely hard. Okay, no one should be able to predict the collision. Essential for security. Basically what kind of security? Digital signatures and file integrity, that we have seen in the last class. Alright, so last video. Next, how to resist the collision. Why it is so hard? Basically, SHA-256 is an hash function that produces 2 to the power 256 possible outputs. So imagine it is 1.16 into 10 to the power 77 possibilities. It is again a huge number. Alright, even with that huge computing masses, the chances of finding a collision by brute force is astronomically low. Alright, it is very low possibility to have the collision, as because the number is very high. Alright, it is out of our imagination. So now some example of weak hash algorithms are there. What are those? Let's see. MD5 and SHA-1 are broken. Alright, do not use that hash function if you want to use it for hashing purpose. Successful collision attacks exist. Alright, so basically collision attack exists, and some people knows the kind of where it will have the collision, so it is not safe. Alright, don't use for password or secure data. Collisions are unavoidable, but they can be minimized. Alright, that can be minimized. Use strong modern hash functions like SHA-256 or SHA-3. You can use this kind of hash functions. So hashing in cybersecurity. Let's look at the hashing cybersecurity perspective. So hashing has many uses, but well focus on two things, that is password storage and data integrity. Alright, password cannot be stored in a plain simple text. Alright, for authentication purpose, otherwise there's a huge chance of leaking the data. Alright, so password, again understand, password storage and password managers are not same. Why they are not same? Password storage is basically you need to verify whether two password are correct or not. Alright, password managers means must retrieve the password in clear text. So both are not same. Manager means it have to retrieve the password in a clear text, but storage means it should not be in the plain text format. It just have to authenticate whether it is correct or not. So authenticate needs confirmation, not the exposure. Alright, very important point. So why secure password storage matters? Why does it matters? So basically many websites stores user password directly in the plain text format, so it is not safe. Leaks can expose all linked accounts, and most user reuse password across platforms. That is very risky. So it is a human psychic that we use 2 or 3 password everywhere. All right, that is commonly people will be using the same passwords almost in every platform. That is very risky in nature. All right, that is why password should not be leaked. Now 3 common insecure practices are there that you can avoid. First of all is storing password in plain text. You should not be stored password in plain text. Basically I'm talking about server side, that is websites and all, should not be storing it in plain text. Next is using deprecated encryption methods. All methods you should not be using, or you should not be using in weak or insecure hash functions, for example MD5 and SHA-1. all right, these are very weak. One example that is RockU breach example. All right, RockU stores password in plain text and it has been leaked. That is 14 million password has been exposed, resulting in RockU.txt now widely used as password cracking. All right, it is also stored in Linux, that you can find in this particular directory, usr share word list RockU.txt, and you will find all the password. It is there in Kali Linux and also other distros for Linux. All right, next, cracking password hashes in the offensive perspective. Let's see what are the perspective of offensive ethical hacker. So the goal is very simple. First, you will, even if you get the hash value, you need to do what? You need to identify the hash type and then crack and then identify the recover the password. That is your task as an offensive ethical hacker. All right, offensive hacker. So use tool. They'll be using some tool for the context for accurate recognition. All right, so hash, some tools are there. What are those? Basically hash id and hashcat. You can use often unreliable without prefix. So again, you have to know something called prefix. All right, let's see what is prefix. So basically all the hash values will be stored in this format. Basically all, you can see this whole format. Again, it will be divided into few parts. That is, here you can see it is format is 4 parts. What are those? First is again Linux password. It is stored in this directory, that is etc and shadow. All right, and the format is prefix, option, salt and hash. All right, there are 4 types of formats are there that you need to know. First one is prefix, second is option, and then salt and hash will be there. All right, so combinedly they will form the hash value so that no one can predict it. All right, if you have to decode the password, then you have to know all the prefix, option, salt and hash. All right, that is quite difficult in nature if the hash function is quite good. All right, so what are IDs? IDs are nothing but hash function type. All right, what are the types? You can see some example of hash prefix. So what are the types? Y for yes script, 7 for script, 2b for bcrypt, 6 for SHA-512, and 1 for MD5. All right, legacy. So all these are hash function types. All right, you can just mention what are the types. So here it is 6, you can see, so that means it is SHA-512. all right, so ID, it will have one ID, which algorithm, hash algorithm you are using. Next is salt, some random string will be there to make more unique in nature. All right, third one is hash, the final encrypted password, and the last one is parameter, that is optional in nature. Extra settings will be there in order to make it more unique. All right, so these are some commonly used hash functions. So how you can check the integrity of any file? Basically any file you take, how you can check the integrity is, that is SHA-256 sum. You can directly write the hash function algorithm and then you can write the file name. All right, this way you will find the integrity. All right, the value and integrity. So next is HMAC, hash based message authentication. How do you authenticate the message? So basically it will combine the secret key and then it will check the hash function to verify it. All right, so integrity is nothing but the data, is it the correct one or is it the original one? Authenticity is whether it is a trusted source, where it is coming from. All right, both have to be checked. So this is how the algorithm looks like. Basically 2 times it is being hashed, and then what is the algorithm is key and inner padding. So there's something called inner padding, both will be XORed, and then it have to again combine with text, then both all the 3 combination will be forming hash function. After that again it is combining with key and outer pad, and then hash function output. So all these 3 are combined to get again the hash function. At the end it is HMAC, that is hash based message authentication code. This is how they authenticate the messages. All right, so that is it for the part 3 of cryptography. I hope you have understood the whole video. If you haven't understood, you can rewatch the video so that it becomes more clear. All right, so that's it. Keep supporting me and don't forget to subscribe the video. That's it. Thank you.